All right, guys, good morning, good afternoon, good evening. But yeah, greetings to you all, guys. How are you doing? Are you fine? Can I get confirmation if I'm audible or not? Can you all hear me? Can somebody hear me? Will you please confirm?
Yes, so we can hear you.
All right, fantastic, great. Thank you for that. Yeah, so let's get straight into it, guys. Welcome and thank you very much for joining. I appreciate that because it does tell me that you are very much committed to doing very well in maths in the year 2026. We're gonna be together in this journey and meet regularly and hopefully show you a few things that will be very helpful to your marks. I think marks is everything at the end of the day. But just before we get right into it, just thought maybe I should do some introductions or go through a few things so that when we do other lessons later on, it's just a standard. Everything is just standard. All right. This is recorded. It's going to be uploaded on YouTube. It's also been live streamed at the moment. So those who have missed out will have an opportunity to catch up then. All right. So I'm just going to give a bit of a background about myself so that you understand who you're dealing with or maybe who's teaching you. And then we'll look at the lesson format and expectations, what I expect from you, in as much as you also have an expectation from me. And then we'll look at the ATP, which has been communicated to teachers across the country. So hopefully your teacher has a copy of this ATP, which I have. Although we're following CAPS, I mean, if you are IEB, you don't really have to worry. I mean, number patterns, for example, we're going to start with that. Number patterns are number patterns. That's essentially the same. I teach in an IEB school, so pretty much know what I mean by that. Okay, let's get straight into it. Okay, so you may have seen this, maybe this photo around, but yeah, this is who I am. My name is Reba Honest. The surname is Khabana Khosi. But students often struggle with the pronunciation of either my name or surname. So most students refer to me as Mr. G. So you are welcome to also use that. Feel free to use that. My academic background. So I have a BSc in Maths from University of Pretoria. I've done a PGCE in Senior and FET Maths with UJ. So that means I teach basically from grade 7 to grade 12. I've done a bit of postgrad as well, honors in computer integrated education. But my teaching experience comes from, dates all the way back from formally, so 2016 or 17, somewhere there. But I have been tutoring since 2010. So I taught at my former school, Pinagare, there in the Northwest. From there, I was with St. John's College in Horton. Then I went to Grey High School in Port Elizabeth, now Gqeberha. And then I've recently joined Crawford International College. That was last year. So that's been my journey, and my specialty really is mathematics and further studies mathematics. Once in a while, I do help out in other subjects, but that's if the demand for maths is not that much. Okay, so that's that. That's about me. And then how we're gonna work is I would expect each one of you to have a book, please. It doesn't have to be the book that you use at school. I would actually suggest you have a book for this particular sessions because we're gonna build up. There's gonna be stuff that I say. I'll give you questions to try and work out on your own. So please have a book, have a pen. If you wanna work with a pencil, that's still fine. I know some of you like being neat and all that, so you wanna rub out stuff. So a pencil is also fine. But most importantly, you've got to have a calculator. I'll also show you my calculator here. I mean, I say this to students and then they laugh and it's like, but I promise you, I'm going to teach you how to use your calculator, all right? I mean, yes, you may think, yeah, you've been using this thing since grade 8 or so, but trust me, you're going to learn new tricks and how to use that. So please make sure you always have your calculator. The standard one that is recommended is the Casio FX82ZA Plus. There is an advanced one. I use an advanced one simply because I teach further studies maths as well, but they pretty much have the same basic features that you need to at least get an 80% in mathematics. I need you to be open-minded and think outside the box. There's going to be stuff, there'll be curveballs here and there. We try and make this maths thing very fun. I'm not going to be too formal such that you feel like now you're in a disciplinary setting and that kind of thing, but you see, we're going to have fun in here. I believe valuable learning for that matter, takes place when there's fun. So we're going to have fun in here. So another important one, this one is very critical, and please make sure you hear me on this one, okay? Mathematics is a language, all right? I promise you, just as you do a home language and an additional language. I mean, your teachers in language, they will emphasize or make emphasis on grammar, on spelling, and all those kind of things. We also make a big deal of that in mathematics. I'll take you through a session just before you write your junior exam. I'm going to take you through an exam prep session and show you how we actually mark your scripts. And I'll show you the mistakes, maybe even before the exam as we go along. I'll show you the common errors that students make in metric marking and all that. And I hope you avoid that, all right? What I've also seen is that oftentimes when we tell you not to do something, you do it. But please, please, I beg you, make sure you listen and you actually understand. If you do not understand, let me know. And while at that, let me also say, please, if you feel I'm too fast, maths teachers, we have that weakness, but let me know, raise your hand, put text in the chat section. I'll try and also be mindful of that. So mathematics is a language. We have words that we use in maths, and we don't just use words in mathematics. Those words actually have meaning. I'll tell you, one of the things I told my matrics last year is the reason you struggle with a question is oftentimes is because you don't read what is being given in the text. You want to rush to the question and solve, but you have not actually given yourself time to read and understand what you have actually been asked. And looking at the past papers from last year to the years before, examiners are catching in on this. They are catching you a lot on this because they know you don't read. And I will give you a classical example when we do the geometry, Euclidean geometry in particular. You will see how important it is to read and how much it pays off. The same thing with the topic that we're going to do today. We're going to look at quadratic sequences. You did this in grade 11. So it's a nice revision, a nice way to start off. And while at that, please note that grade 12 mathematics assumes that you know 100% of grade 11. The same way grade 11 mathematics assumed that you know 100% of grade 10. So what I'm trying to say is in any exam or test that you're going to write this year, you may expect a question that is at grade 10 level, a question that is at grade 11 level, or even earlier than that. You will see when we do geometry as well. So you can never say, and now that I'm in grade 12, I'm going to forget what I've done in grade 11. That's actually very risky. The grade 11 is the foundation that has carried us to where we are now. So if you have forgotten some stuff from grade 11, I really advise you to, go back to your books. I hope you did not throw those books away, including your textbook, but it's fine. We will try and make provision if that is the case, all right? So please, there are words that I'm gonna use. I will try and explain these words and pay attention to that. If you need to have a glossary book, do that. That helps as well. If you want to write the definition of a function, what the word quadratic means and all that, I'm going to explain this because it is in the understanding of these words that you will actually understand maths and know what you are actually doing, and also understand what the questions require of you, okay? There are symbols that we use in mathematics, and I will also explain what a symbol means. I'm not just going to use a symbol. If it happens that I use a symbol and you do not understand what it means, please feel free to ask me what that symbol means, all right? Very, very important, because you get penalized for using symbols incorrectly in the end of year marking, all right? Another key one is please don't be shy to ask questions. All right. I know the common thing in a maths class that happens is, do you understand? And everyone goes, yes, sir. Some keep quiet. And in keeping quiet, they are trying to say, we don't really understand, but we are shy to ask. And that's because you feel like your peers are going to laugh at you and that kind of a thing. If you are not shy to ask a question or express yourself, please feel free to do that. If you are really shy and you feel like you cannot do this, you can send a direct message. You can put up a message in the WhatsApp group. What we're going to do for a certain period of time in a day, we will open up the WhatsApp group so that you can send a message. You can post a question. Some of you will have homework questions during the week. From next week, you're going to get your first homework, and then maybe you struggle, you need some help. I will try and avoid doing the homework for you, but I will do my very best to help you understand the question that is being asked, okay? I do not believe in providing solutions, in providing memorandums. I believe in getting students to think, because at the end of the day, when you sit in that final exam, I am not there to give you memorandums. So I don't want to train your mind to think that I will always be there to provide you with your solution. But I want to train your mind to always find a way out when facing a mathematics problem. That is the whole thing, all right? So that is that. Moving on, this is our annual teaching plan. This is the plan that has been sent to maths educators. I am part of the FET Google group for maths teachers. It's a national group in the country. So this is what has been communicated to teachers who are following the, or schools that are following the CAPS curriculum. So as you can see, for term 1, you've got about 11 weeks, and the topics that will be covered, it's number patterns, sequences and series. Sequences and series, that's the little new thing that will be added to your prior knowledge of number patterns. Then we're going to look at functions. Some of you, I mean, not some, but you have all worked with functions. You have worked with an equation. You've worked with an algebraic expression. You have worked with plotting graphs and all that. So we're now going to give you a formal definition of what a function is. We will look at an inverse of a function. By the way, to understand what an inverse is, you need to understand the definition. So that's another thing about mathematics, right? Topics are very interlinked. We build on previous knowledge. So do not forget what you have previously learned. And then we will look at my favorite topic there, the trigonometry. We will have fun there. You will see again how trigonometry is very linked, closely linked, well integrated with algebra. So that thing of solving for x, that thing of adding like terms, that thing of squaring stuff, foiling and all that, please make sure you master those little things, because they are very crucial in these other complex topics. So this is how things are looking at term 2. We're going to look at Euclidean geometry, analytical geometry, then an entirely new topic, differential calculus, including polynomials. We will also do a formal definition of what a polynomial is, so that actually you understand calculus much better. And then term 3, we will then do the minor topics, and you will see why I look at this as minor topics: finance, growth and decay, statistics, counting and principles and probability, and then you go into your trial exam. Now, why do I say these topics are minor? Why do I say finance is minor? Why do I say stats is minor? Why do I look at counting, principles and probability as minor topics? I want you to look at your final examination format here and have a look at the first paper that you obviously will be writing. Some of you will write this, June, you write on different dates based on your province, but the final we will all write at the same time. So look at counting principles here, look at finance here. If you look at these topics, and that's why I'm saying they are minor, they only count about 15 marks in your paper. It's, by the way, it's plus minus. It could be a bit more than 15 or less than 15. So these are minor topics. In other words, even if you master these topics, you will not pass paper 1. I want you to look at statistics. Statistics is only 20 marks of the 150 marks of your paper 2. No matter how much you master statistics and love statistics, you stand no chance of making it in paper 2. all the previous topics that are done in term 1 and term 2, according to this ATP, they are actually major topics. And I want you to see something so that you understand why sometimes I will spend a lot of time on a particular topic and very, very few lessons on one topic. If you look at functions and graphs, and then you look at differential calculus, that's 70 marks, almost 50% or half of your paper, which says to me, if you do not understand these topics thoroughly, you do not stand a chance of passing paper 1. In addition to that, it's going to be algebraic expressions, equations, and inequalities. All this is grade 11 work. So your grade 11 is only giving you about maybe 26 marks into your first paper. Then number patterns, which is what we're going to start with. These, for me, are the heavy topics which I think if you will give yourself time and make sure that you master, you then stand a very good chance of hitting a very simple, straightforward A in your paper 1. If you look at paper 2 again, I want you to look at trigonometry and Euclidean geometry. The two topics are amounting to 90 marks, which means if you struggle with trigonometry, you struggle with Euclidean geometry, you're not going to make it for paper 2. So as a result, these are the topics that I will spend most of my time and energy on to make sure that you at least try and appreciate and understand or maybe develop a love for, because without these topics, you're not going to make it for in mathematics. I hope you do see what I'm talking about. These are suggested assessments for the year, but I mean, they do vary from school to school, except for the final examination. So, I mean, the teaching pace differs based on class sizes and I mean the pace of the educator as well. So please, this is very fundamental, very important. I need you to note this and so understand why we're gonna sort of, you know, focus so much on this one topic. It is because of the contribution of that topic in your final examination. All right, and I think my story is going to end there on the reviewing the ATP. We're going to get straight into it. Week 1, 2, this is just the ATP in more detail. As you can see, our first point is to start off by revising number patterns, where we will have the constant second difference. You see these words, you see, as I said, you got to pay attention to the vocab, to the words in mathematics, okay? Constant, second difference, consecutive terms. You see, the general term, quadratic, these are very important words of which if we do not understand, then we will never know what we are doing when it comes to the quadratic number pattern. So, but anyways, enough about that. Let's get to the maths. I hope my little talking has given you enough time to grab a book or something to write on so that you can follow as we go through. I'm gonna pause at some point and ask you to solve a problem. Maths is one subject. I say it's a doing subject here. It's not a spectator sport. Remember, you know, a spectator sport is a sport where you watch, right? You know, soccer, you watch and you comment, but Fana Bafana, you know, the coach should have done this and that. You're not in the field. But in maths, it's not, it's different. You are the player, okay? You are the one who gets dirty, who gets injured, who gets kicked and all that in the field. So I'm gonna need you to come on board. When I give you a problem, I need you to give it your honest try. Don't worry, I'll try to be very fair and give you examples, enough examples that will equip you to be able to do a problem. So I'm not gonna have impossible expectations. All right, so let's start here, the quadratic sequence. Why is it called quadratic and so forth? Okay, we're gonna look at that and you will see I will often kind of put emphasis on the why, because that covers 60% of your understanding, right? So I'm gonna start off by writing a number pattern here, 3, 11, 21, and then 33. Okay, and this goes on and on and on, right? Now, it is very important that whenever you are given a number pattern, so sometimes the examiner will be very nice. I will show you questions as well. There are questions where you can see the examiner was in a very good mood, but there are questions where you can see here the examiner woke up on the wrong side of the bed, and that's where what seems to be obvious is not so obvious. So as I said, you got to pay attention to the words that are used in mathematics, okay? So the key word here is quadratic. And what does quadratic mean? Okay, so in grade 10, you would have learned about a quadratic equation, right? Something like this: x squared minus 2x plus 1 equals to 0. And the reason this equation is called quadratic is because the degree of the equation is 2. So in mathematics, the word quadratic suggests degree 2, or at least think of 2. Think of something happening twice, something like that. So in the context of an equation, a quadratic equation then would suggest that you need two solutions. So you learned about this in grade 10, and then in grade 11, we extended this. We started talking about nature of roots, or nature of solutions, maybe. And then you learned that roots can be repeating, and roots can be distinct, and all that. In this case, this beautiful equation here can actually, the left-hand side can be factorized into something like this. And we're going to get x equals to 1. And I know you're going to be like, but why are we not getting two solutions? Well, if you understand nature of roots, then you understand, oh, okay, x equals to 1 is actually a repeated solution. It's a repeating solution. It occurs twice, basically. And I'll show you the visual of this, what it means on a graph as well when we talk about functions, of course. But we were explaining the point quadratic. And I'm deliberately linking this to the equations because quadratic number patterns are not any different from solving equations, are not any different from the quadratic function. We're just working in a different space. Okay, talking about space, please take note. In sequences and series, we often use n, right, instead of x. And one of the things that we say is we want this n to be a natural number. Natural numbers, you learned about this in grade 8 or 9. These are counting numbers from 1, 2, 3, 4, up to infinity and all that. So in other words, we don't expect you to, on a given day, think of term number -3. You cannot think of a term number -3. When you think of term numbers, you got to think of natural numbers. So your first term, second term, and so forth. And this is also fundamental. You will see that when we do problem solving questions, or at least complex procedure questions. Now, what makes a sequence quadratic? Please make it a habit, especially if it is not stated in a question. Sometimes they say, given this sequence, determine whether the sequence is quadratic, linear, or maybe geometric. All right, sometimes they ask a question that way. So you need to know what makes a sequence quadratic. What makes a sequence quadratic is the following. Number one, it is the fact that you will have a second order of differences. Now, what is the first order of differences here? The first order of differences here is the difference that I'm going to get by subtracting the first term from the second term. Maybe I should say that slowly because this is also very important. We see rookie mistakes here. Okay, so please take note, guys. The number 3 is term number 1 of the sequence. The number 11 is term number 2. The number 21 is term number 3 of the sequence. So whenever you're going to work out a difference of a sequence, you've got to go as follows, all right? You've got to take a term and subtract the term that comes before it, okay? We see things like this. We see students doing 3 minus 11. I promise you're going to think I'm joking. And we see people saying the first difference here is going to be a -8. All marks are gone because that might just be a breakdown. So please make sure when you find a difference, and we deal with the difference when we do a quadratic and a linear or arithmetic number pattern, always go T2 minus T1, all right? So that's how we go about it. So we're going to go 3 minus 11. No, we're going to go 11 minus 3 to get +8. I do hope that you will pay attention to that as well. If you are not sure, if you know that I'm not that confident in my mental mathematics, please, then feel free to use a calculator. It doesn't matter whether other students laugh at you or not. That's how they work. Not so confident with your mental maths, please. That's why we say calculators may be used. All right. And of course, you got to be fast if you are using a calculator. Be fast as your brain would be if you are doing this off from memory. Okay. So this here, these numbers, by the way, and I'm mentioning this again, I said mathematics is a language. So pay attention to the words that I'm going to use here because these words might be used in an exam. Okay. Are you with me? I wish someone could respond. All right. Feels like I'm talking alone. Okay. If someone doesn't mind, please. All right. So we've got 8, 10, and 12. These three numbers, 8, 10, and 12, are referred to as the first order of differences, or first difference, okay? It's a sequence, as you can see. It's a pattern. And how do I know that is a pattern? Because if I further subtract, again, I'm not going to go 8 minus 10. I'm going to go 10 minus 8. I'm getting a 2 here. And obviously, you can see it now. You're going to go 12 minus 10, and that gives you a 2 as well. And this is what we call the second order or the second constant difference. The word constant, those who take science will know the word constant means fixed, does not change. Something that is a constant, it is something that will remain the same. And surely this is a constant difference because we are getting 2 right through, which means I can make a safe assumption that, well, look, there must be a 2 somewhere here, which means then I can know the next number here must be 14. And if I know the next number there must be 14, surely I can know what the number after 33 is, and so on and so on. So please take note. We have a first order of difference. We have the second constant difference. So what tells us that a sequence is quadratic is this part here, when there is a second constant difference. It's not just a difference, it's a constant difference. The second difference must be constant, okay? Second constant difference. When we have a second constant difference, then we know we have a quadratic number pattern. Another thing that I should bring to your attention is this term here. The number 8 in this case is known as the first term, listen to this please, the first term of the first difference of the quadratic number pattern. And I'm saying this again deliberately because I've seen exam questions saying the first term of the first difference of a quadratic number pattern is this. And students mess it up. They think that the examiner is referring to the first term of the quadratic number pattern. So please note that this number here is actually known as the first term of the first difference, or the first sequence, the first difference of sequence, or first sequence difference. I don't know. You'll pardon me. I'm still not at work, so my English is also subject to correction, but not the maths. All right, cool. Then, guys, we get to this one. Now, this one here, this one is actually the first term of the quadratic. Okay, so I need you to be aware, be conscious, be alert to the fact that in a quadratic sequence, you have a sequence, okay? And what is that sequence? If you would think with me here, you would note that that sequence is the arithmetic sequence, and we will talk about that in our next lesson. Okay, now a few things that you have been told. I do not have the luxury of time to show you where this comes from, but I know by now you all know the following. you know that the second difference of a quadratic number pattern, or the second constant difference, is equal to 2a. You know that. You also know that the first term of the first difference is equal to 3a plus b, right? And you also know that the first term of the quadratic number pattern is equal to a plus b plus c. What is this a, b, and c? What is this? Where does it come from? Well, it comes from the general term of a quadratic number pattern. The general term of a quadratic number pattern goes an squared plus bn plus c. Well, tell me if that does not resonate with f of x is equal to ax squared plus bx plus c. The only difference is here, our independent variable, which is x, can be any real number. Whereas in this instance, our independent variable n is the term position and it must be a natural number. What makes them both quadratic is this exponent there, degree 2, as I said. So whatever, that is why, by the way, remember this is a parabola, right? This is a parabola. You can either have a smiley face or a sad face. So that is why in a quadratic number pattern, we can have questions like, what is the smallest term? Or determine the position of the largest term. That actually comes from the fact that in a parabola, when a parabola is in a set form, then you have a minimum. That's where the smallest comes from. When a parabola is a set face like that, then you have a maximum. So that is where these questions come from, okay? So it is very important that you actually see the connection patterns and functions, okay? I hope we capture that quite well. All right, as I said, I'm gonna be quite fair. So I'm going to do two examples. In fact, this was supposed to be an example. So I'm gonna find the general term here. Maybe not, okay? Maybe not, or maybe I don't know. But let's do it, let's do it. Let's maybe answer the question which says, so here's the question. Let's do it for everyone. The question says, which term in the sequence that is given, which term, so guys, you need to listen more to what I say than what I write. Sometimes my handwriting does the opposite of what I say, but I promise you what I say is often correct than what I write. So which term in the given pattern is equal to, let's say 497? Which term is equal to that? So obviously, they are saying here, we have given you the term value. So we have given you Tn. So find for us n. Find us the n value that is going to produce 497. This n value will be substituted into this equation or formula, an squared plus bn plus c. That's where we're going to substitute it, right? So we have already devised this, and I'm sure one of you, if anyone is excited to do this, you have already worked this out, but maybe let's do it in case. We know 2a is equal to the second difference, and the second difference is a 2, therefore a is equal to 1. We have also noted that 3a plus b is equal to 8, and so I'm going to substitute here, and then this is 8, so b is equal to 8 minus 3, which is a 5. Once again, some of you, this is not important, but for some students, it is actually important to write 8 minus 3. Again, psychology of mathematics, sometimes the brain plays you so much and you find yourself having written -5 instead of a +5. So if you need to be that meticulous and write down every step, please do that. Okay, then we also know that a plus b plus c is equal to the first term, and the first term is a 3 in this instance. I'm going to substitute the value of a, that's 1. The value of b is a 5, and I'm looking for the c. So all this is equal to 3. If you need to do 6 plus c is equal to 3, so be it, okay? And so take note in this case that to find the value of C, we will have to do a 3 minus 6, which is basically a negative 3. So just like that, we have the value of A, the value of B, the value of C. So that means Tn, our general term, will be n squared. Take note that I do not write the 1 because we know in mathematics, any number is a product of itself and 1. So it's part of the invisible maths. We don't have to write the 1. This is 5n, and then that is a negative 3. So this is our general term, okay? Remember what the question requires is it does not want us to find term number 497, but it wants us to find the value of n that will produce 497. So we are given Tn, which is 497, and we're going to solve for n. And look at that. You have a quadratic equation. Now, you can either work on the left-hand side or on the right-hand side. I prefer keeping the squared term positive. So since my squared term is on the right-hand side, I will rewrite my equation like this, 5n, and obviously we're gonna add a negative 497 on both sides. I know we have a street way of saying it. We say we take 497 to the other side and all that, which is bad language, but you know what? If that helps you, that is absolutely fine. So I'm really happy if you know what that means, okay? So that is that. Okay, please take note, there is nothing wrong in rewriting the equation. I know some of you prefer really working on the left-hand side. So there is nothing wrong in rewriting this equation like this, saying n squared plus 5n minus 3 is equal to 497. And then you do this later on. There's nothing wrong with that. You can do that. Remember, if I say A is equal to B, then there's nothing wrong in saying B is equal to A. Those are what we call equivalent statements. They are statements that are essentially saying the exact same thing. So that is what I'm doing here. All right. Okay. Anyways, we get here. Now, when we get here, you have two options. You can factorize or you can use your quadratic formula. Now, I know factorization has been a nightmare for some of us from grade 9 up to grade 10, and we got a bit of a relief when we got to grade 11. So in grade 11, you were introduced to the quadratic formula, which says, oh, by the way, it's given in the information sheet. Your teachers must also give this to you when they set a test which requires this. So x is equal to what? Minus b plus minus the square root of b squared minus 4ac all over 2a. And I'm doing this because really I want to accommodate everyone. I don't want to go through the flexing of factorization. Now, take note, guys, that, excuse me, this is in terms of x. You will be penalized if you write this in terms of x when you are actually solving for n. So I suggest, please, instead of writing it in terms of x, pay attention. What letter are you solving for in your quadratic equation? It is n. Sometimes it's going to be a p, sometimes it's going to be m, a q, whatever letter, a k. But please, you got to write your quadratic formula in terms of the letter that you are solving for. All right. So we know what b is already. Let's show the substitution. Sometimes you make a mistake in the final answer, and that's where maybe you might get a grace mark in showing the substitution. So B is obviously a 5. And take note that I am using brackets. It is very important that you use brackets whenever you substitute. Whether you are substituting a number or you are substituting an expression, please make sure that you always use brackets. I say brackets save lives. And you're going to see as we progress that whenever you do not use brackets to substitute, especially when you are substituting in front of a negative sign, you will see how often that leads to, you know, some bizarre answers and all that kind of thing. Okay, so let's substitute this. So even if it's a positive 5, I'm going to use brackets. Of course, it doesn't matter here. Even if you don't use the brackets, you're going to get a correct answer. But because we create habits as we practice and prepare for examination, I suggest you always use brackets so that this becomes part of your nature and you don't make such a mistake at a crucial time of writing your final exam. of course, then A is 1. And then what you do here, you're going to go straight into your calculator. And I said I'm going to show you how to use it. And then I want to enter this thing here. Yes. So I'm going to show you how to do that. Okay, cool. So let's do this. We have the following, right? As I said, we're going to use the quadratic formula quickly. So I'm going to go minus, and I'm going to put that. It's fine. No, not 59, but that. And I'm going to go plus, and then I'm going to put the square root, and I'm going to go 5, and I'm going to square that. Take note that the square is outside the brackets, not inside. These are the little things that lead to errors and frustrations in an exam. So that is why I am stressing these, okay? I'm not doing this to insult your intelligence or anything. And I do apologize in advance if I am wasting your time on this part. But please, this is very important. Okay, so our first value for n is a 20. So we know now that n is equal to 20, or how do I know that there's going to be another solution? Because this thing is quadratic. We have established that whenever you've got a quadratic, you got to have two solutions. And guess what? If the solutions are repeating, your calculator will do the same. Now, I want you to take note of what I did here. I did not press the on button. Most of you run to the on button and it erases everything, and then you have to start from scratch. Instead of pressing the on button, I went for this arrow here, and this arrow here put me somewhere nicely there, and I navigate through the arrows actually to get to this plus sign. And obviously what I want to do here is to get rid of the plus sign and put the minus sign, because our quadratic formula says plus minus. Then I get my second solution, which is negative 25. So let's note that, let's put that down. N is equal to negative 25. But there's something fundamental that I said. I said when we work with number patterns or sequences, we always go for natural numbers. So if you know your number sets, you will note that 25 is not natural. Therefore, we cannot accept a negative n value. So therefore, this is not applicable. It is a solution to the equation above, but it is not applicable in this case. Therefore, we go with n equals to 20. Therefore, we can say T20 is 497. I saw a hand. I saw a hand from someone, and then, well, the hand went down. Do you still have a question there? Was it Bulali or Buisile? I don't know. Who had the question? Or are you sorted?
Yes, sorry, sir. It was me,
Are you okay?
Bunali. Yeah, I'm just looking at the paper here. It's like by the quadratic equation,
Yes.
you have minus 3 there by the value of c. Is it still the
Oh
same
my,
value
yeah,
that you
yeah.
punched into the
Good catch,
calculator, sir?
good catch, good catch, good catch. This was
Oh,
supposed to
okay.
be a minus 500. Absolutely spot
Oh,
on.
okay,
Good
thank you.
catch, good catch. Of course, I would have taken that instead of this. Okay, thank you. Well, my substitution in the calculator, what was it? Yeah, I've got to correct that as well. Let's see. Oh, no, I put the right one in the calculator. Okay. Yeah. But
Yes,
thank you
yes,
for
yes.
pointing that. Very important. Very important. Thanks for bringing that. Yeah, it is a minus 500. Okay, cool. Um, so that is one example. This is classical. You know, when you get a question like this, you know your examiner was in a very good mood, felt like, giving away marks and all that. All right. But then there are some questions that are there to catch you. So let's do another one. Let's do an interesting one. I would rate this as a level 2 question. Is it routine? Yeah, I think it's routine. So look at this one here. You are told to do the following, okay? Um, we know that, so maybe let me write it as it is. So this is what the question says. If negative 2x, 8, 19, and y, blah, 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 is a quadratic number pattern. I will be a bit lazy and use abbreviations. So NP here means number pattern. Determine x and y. Well, the values. So I must actually be very particular here and say determine the values of x and y. So it's solved for x and y. And I think this is actually going to be more of a complex procedure than routine. Okay, so how do we box this, guys? Again, keywords. This is a quadratic number pattern. What have we established? If there is a quadratic number pattern, we must have a second constant difference. So we're going to follow that and get some equations, and hopefully those equations will help us to find the values of x and y. So let's do this. Remember what I said? I said when you find your difference, you're going to go term 2 minus term 1, not term 1 minus 2. And this is where the catch is again. Watch now. Term number 2 is x minus, I am subtracting. But please take note, you are subtracting a negative value. You are subtracting a negative 2, like that. And this is where our grade 8 knowledge comes into play, because you know a negative and a negative is a positive. Therefore, this must actually be an x plus 2. So we will not penalize you if you write x plus 2 right away. I just felt I should actually explain why we're going to have an x plus 2 here. Same thing here. I'm going to have an 8 minus x. So take note, I'm going to use semicolons to actually separate this so that I don't get confused. And then what I'm going to do here, I'm going to get a value here because those are just numbers, and that's going to be an 11. Okay. And then here I will get an expression in terms of y, and this will be y minus 19. Remember, this is the first order of differences, right? Then are we done? No, we have to go for the second because we know this is a quadratic number pattern. Now be careful here. Be careful, because what you are doing for this, for whatever is going to go in here, maybe let me color code this. Please, this is where mistakes happen, and this is where marks go away. Whatever is going to happen here, you are doing the following. You are going 8 minus x minus x plus 2. And this is where brackets will start saving some lives here. Okay, you got to use brackets. Without brackets, I promise you, you're going to get a different answer, and you're going to end up with a completely different value for x and for y. So very, very important that you will use brackets, standard procedure, right? Okay, so I have 8 minus x minus. So once again, some grade 8 algebra here. This is minus x minus 2. We've got to add like terms, okay? An 8 and a negative 2 gives me a 6, and then a minus x and a minus x, adding those together will give me a negative 2x. So I must have a 6 minus 2x here. Now, I'm going to do the same thing for the what? For the 11 minus what? 8 minus x. I want you to see where I get all these, okay? So again, this will become 11 minus 8, but then I'll have a plus x there because a negative and a negative gives a positive. So please be mindful of that. So this here will be 3 plus x. If you like, you can write it as x plus 3. Remember addition. We say addition is commutative. In other words, the order in which you add does not matter. A plus B is the same as B plus A, because 2 plus 3 is really the same as 3 plus 2. But that is not the same thing with subtraction. You cannot have the same answer for A minus B and B minus A when those values are different. In other words, 2 minus 3 will not give you the same answer as 3 minus 2. The one is negative 1, the other is a positive 1, and these are completely two different values. So while you can just swap numbers around with addition, you cannot do that with subtraction. So please, I will throw in these little things here and there because they're important for other topics. Okay, so we get 3 plus x there, and if you followed well, you will agree with me that there's got to be a y minus 30 here. Now, we're going to use this principle. What is this principle? In the second difference, all these numbers must be the same. So if that principle is true, and I believe it, and I do not doubt it, then surely 6 minus 2x must be equal to 3 plus x. Not only that, furthermore, I can go 3 plus x must be equal to y minus 30. Now, if you notice here, when we have two equations, one equation has one letter, which is x. That's nice. We always want an equation like that. The other equation has two letters, x and y. So you cannot start with this troublesome equation. You cannot start with this. Start with this one because it is simple. You have the same letter. And then you're going to substitute that because this is x. It will be the same x as this. So you're going to substitute that, and then you'll be able to solve for y. So let's see. How do you going to, I don't know how you want to go about this, but it doesn't really matter. I'm going to go 6 minus 3. Watch. I'm going to go 6 minus 3, and then I'm going to go x plus 2x because I want the letter that I'm solving for to be always positive. So that's 3x. This is 3. So that means x is 1. So because I know x is 1, I'm going to substitute here. So 3 plus 1 is actually y minus 30, which means that 34 is equal to y, or if you like, y is equal to 34. And just like that, you have sorted this out. All right. Now, I want to pause here. I've been doing a lot of talking, so I'm going to pause here. And for the next 8 minutes, I want you to solve a problem. And the whole idea is to just check, maybe for you, just check, have you understood what we have done so far? Do you still remember some of your grade 11 concepts? So I'm going to put this up here for you, and I want you to actually try this out here. This is a question that was asked in the Eastern Cape trial exam. Don't go to the memo. Please, please, please do not go to the memo. Just sit there. It's you and your book, and I want you to try this on your own. See if you can answer this question. Now, let me teach you a little trick in terms of time management, okay? If a question is 4 marks, you're not supposed to spend more than 4 minutes. If a question is 1 mark, you're not supposed to spend more than 1 minute. Okay, now I have not done a question like this. So like I said, I'm going to be very fair. So I'm not going to expect you to do this question, okay? We will talk about these type of questions shortly. But what I need you to do for now, just to touch base and see if you can do this, I want you to do only these two questions, 2.1.1 and 2.1.2. We will talk about this one later when I have actually shown you an example on how to do it. So since this all amounts to 5 marks, I will expect you to be done in 5 minutes. So after 5 minutes, I will unpause and then we look at the solution. Or maybe you will tell me the solution. So let's just have a look at the solution. Let's see if you are doing the right thing, if you got the 5 out of 5 marks in this short space of time. So we are told, number one, we are told that this is quadratic. So we know already it's quadratic, okay? So there must be a second constant difference. And we're going to find A, B, and C, and then just like that, we are done. This is a routine procedure question. You don't really need to think hard about this one if you have practiced your book work. All right. So the catch, whenever there are negative numbers, I promise you, you know that there is a catch. And again, they want to say, do you understand the principle that you have to actually go T2 minus T1? And please, if you have to literally do this in your calculator, -4 minus a -5, so be it. You're working for your marks here. You don't want to mess up, all right? So be it. So this must be a +1. And of course, I do hope I have someone doing a VAR check there, so that I do not actually mislead you by making errors here. Okay, so please do verify. If you are very sure that what you are doing is right, please make sure that I am writing the correct things. So If we have all done this correctly, we must have, for the first order of differences, we must get 1, 3, and 5, which means the second constant difference is 2. And I get students sometimes going like, so that means the second difference will always be 2 for any quadratic number pattern. No, it's very, very dangerous to make such an assumption. So we know we're just lucky it is a 2 in this instance. And it so happened that in the example that was given, it was also a 2. So that's not always going to be the case. Okay, let's show all working, guys. Even if we know that a is equal to 1, at least let us show that we do have an understanding that the second constant difference is equal to 2a. Then we have 3a plus b will also be 1, which means that 3 times 1 plus b, that b looks like a 6, my apologies, but it's a b, right? So b here will be 1 minus 3, which is a negative 2. And finally, a plus b plus c, and I'm going to be a bit lazy here, 1 minus 2 plus c should give me a negative 5. So a 1 minus 2 is a negative 1, and we're going to add that, or rather we're going to go negative 5 plus 1, that should be a negative 4. Okay, which means my general term, which is Tn, or the nth term, will be as follows: n squared minus 2n minus 4. Do I have somebody voting for this? Is there someone in agreement? We're in a democratic country, so let's vote. If I'm incorrect, it's fine. The majority shall rule. Can someone show there with their hands? Who got the same thing? Okay, perfect. Thank you, Ashley. So Tn is n squared minus 2n minus 4. Perfect. Now, to calculate the 35th term is very simple. We're going to go T35. Show that T35, please. And then remember, you may not be penalized for not showing brackets here, but remember, this creates a habit which may be costly later on. So please make it a habit to use brackets. Okay, so I don't know if my calculator is functioning properly, but I get 1151. I don't know about you, but hopefully that is also correct. So if you got this, you are in the money. Well done. How it usually works out is they may just give you, maybe if you did this, they might give you 1 mark there or 2 marks there. And then for writing the final answer like that, you might get that. And then maybe for method, you get 2 marks, something to that effect, just roughly speaking, for that 4 marks. And then of course, the 1 mark will come there. Now let's do questions like 2.1.3. As I said, I'll show you this one. Now, if you think about it, again, as I said, we don't just throw words in mathematics. Words have meaning, so you got to pay attention. There are 2 terms. Consecutive means one after the other. So there are 2 terms in this particular quadratic sequence that come one after the other. And in the between those 2 terms, listen to this. Which 2 consecutive terms of the first are actually, this is another very important clue, of the first differences will have a, oh guys, listen to this, a product of 1,155. Now, I'll tell you, sometimes this question is read as between which 2 consecutive terms will the difference be 1,155. That's how it is often read. And I can tell you, a student who has practiced 3, 4, 5 past papers, which have a question like this, such a student would have actually just gone straight and said, oops, I actually know what this means. But that's not what this question requires in this case. In this case, the question is saying, look at the first order of your differences. So 1, 3, 5. If you like, you know there's going to be a 7 and so on. So they're saying, look at this number pattern, because that is what your first difference sequence is. That's what these differences are your first differences, but they make a sequence. Okay, so looking at that, they're saying there are 2 terms here, one after the other, and these 2 terms will give you a product. In grade 8, we learned a product means multiplication, or the word product means you multiply. All right, so there are 2 consecutive terms that will give us a product of this. Question is, what are those terms? And then we're like, I was never taught this. So let's think together, all right? We're not gonna panic. we're just going to try and put meaning into the words that have been presented in the question. So we know now the correct sequence is 1, 3, 5, 7. We forget a bit about the quadratic. And then we want two terms that are consecutive. Now, in terms of number patterns, all right, we want terms that are consecutive can be represented as follows. Your first term can be Tn, and the term that comes after Tn will be Tn plus 1, because the order of natural numbers is you always add 1 to find the next number. All right? So that's how it's going to work. Now, do we know Tn for this number pattern, for this first differences? Well, we don't, so we need to find it, right? So let's see. There's a 2, there's a 2, there's a 2. So that means Tn for this is 2n, and I think it's 2n minus 1. In our next lesson, you'll definitely know how to find this as well. All right. So it's 2n minus 1. We can actually check it. Check with term number 3. If I substitute 3, will I get 5? 2 times 3 minus 1. Oh, yeah, surely that's a 5. You can go on and check with 4 and all that if your faith is not yet there enough yet there, but that's fine. That's what you can do. So Tn is 2n minus 1. This Tn, please take note, this Tn is that Tn. So what do we need to find now? We need to find Tn plus 1. Tn plus 1 means in the place of n, we got to substitute n plus 1. That's what it means. So this will be 2n plus 2 minus 1. So this becomes 2n plus 1. So this is what Tn plus 1 is. Now the statement says the product of these consecutive numbers or consecutive terms is 1,155, which means when I multiply Tn by Tn plus 1, so a term and a term after it, I must get 1,000. Something's happening to my pen here. Okay, it's back. 1,155. So what is Tn? Well, Tn is 2n minus 1. And you know by now, if you're going to have an algebraic product that includes what you call a binomial or a trinomial, whatever, you got to use brackets, right? Okay, cool. Now, some of you are going to go FOIL. That's absolutely fine. But for those of you who remember this thing called difference of two squares, you will note that this will simply FOIL to 4n squared minus 1 is equal to 1155. Because it's dots. You just square the 2n, which is 4n squared, and then you just square the 1. It's a 1. All right. And now there's two ways to go about this. I usually say you can do it the street way or you can do it the formal way. But I'm going to go to the streets for now. So I hope you all understand why I'm going to have 4n squared equals to 1156. I have added 1 on both sides. Then I want to get rid of the 4. So I'm going to go 1156 and I'm going to divide that by 4. So I'm going to get n squared is equal to 289. Once again, pay attention. It's a quadratic equation. It's just that it is not in standard form. And I know this is how we're going to do it in the streets. We're going to say n is equal to plus minus the square root of 289. Let's find out if 289 is a perfect square. So you're going to go into your calculator and you will get that, well, n is a plus or a minus 17. But remember, there's a number pattern. When we work with the value of n, we need natural numbers. So here, surely, n is equal to 17. Have we answered the question? No, not fully. We have only found one of the terms, and that is position 17. We need another one. So therefore, this will between the product will be between the 17th and 18th term. Now, the nice thing about maths is maths will always make sense. And as someone solving a problem, you can always check if your mathematics makes sense. And how can you do this? And I will leave this to you to do it. You can literally come to this general term and substitute term number 70 and substitute 17 in the place of n, and then substitute 18 in the place of n, Take those two results, multiply them, and see if they give you 1,155. That's how easy. That's how you can always verify or VAR or double check your answers. That's the beauty of maths. If you know the forward process, you gotta know the backward process. I always put it this way: if you're gonna say to me, you know your way from home to school, then you must know your way from school back home. All right. Bulali, you got your hand up. You have another question. Did I make another mistake? Tell me, where did I go wrong?
No, no, I just had a question. If we're saying it's consecutive, is it possible that we can say the 17th term and the 16th, not the 18th?
So remember this, it's not any two consecutive, right? So that's why they're saying which two. So there's a specific particular two in this case. And another way you could have done this, by the way, and you still get the right answer. You can go try it, is to work with Tn minus 1 and then work with Tn. This should also give you the correct thing. So it would not be that unless by coincidence or yeah, it is the case. You could go ahead and check whether term 16 and 17 will be, but that's not going to be the case. There is a specific two in this case that gives us a product of 1,155. You good with that?
Yes, thank you very much.
All right, cool. Guys, any questions? I'm going to pause for questions now. Kanisa, you've got a question.
Hello, sir.
Yes.
I would like you to re-explain this part where it says 2n is equal to negative 2n, as well as the writing in blue underneath it, please.
Okay, let me just see. I want to make sure that I understand your question. Where I say Tn is what? 2n minus 1.
Yes, yes.
Okay, okay, so basically you want to know where I got this thing.
Yes.
Sorry about that. So you want to know where I got this 2n minus 1.
Yes, sir.
Okay, cool. Fine. Let's do that. So my number pattern is 1357. Okay, let's write that down. 1, 3, 5, and 7. So I know that the constant difference is 2. And by the way, this is a linear number pattern. It's an arithmetic one. As I said, we have not formally learned to do that. Now, an arithmetic, if you will recall, when I introduced the quadratic, I linked it to the quadratic function. Same thing with arithmetic. Arithmetic means linear. We're going to link that to the straight line as well. So generally, for any linear number pattern, the formula is as follows. Tn will always be dn plus c. And this should resemble that famous formula mx plus c. It's just that we're using different letters here, and d here is the difference, the constant difference, and c is the number that you're going to add. Now, I'm going to explain this in a very basic way. You're going to get it. You're going to tell me now the answer. So the difference, the constant difference is this 2, by the way. So the formula says Tn is dn plus c. So this is 2n. If you want to know what the value of c is, I need you, Kanyile, to think backwards. I need you to think backwards and think what could have been the number before the first term of this sequence. Now, I'll help you with that backward thinking. If I know, just watch the pattern here. For me to get this difference here, I would say 3 minus 1. The reverse would be, if I want to know this term, knowing that and that, then watch what is happening here. I would have said 3 minus 2. Do you see what I'm talking about?
Yes, sir.
So I know that there must be a 2 here. So what should be the term here?
0.
Think about it. What did I say here? I said what? I said 3 minus 2. So what should I say here to get this? 1. I should say 1 minus 2.
Then it's going to be -1.
Then it's going to be -1. And that's how I will get that -1.
Oh.
So I promise you, for any arithmetic, as long as you are told this is an arithmetic number pattern, this is how you can find Tn. Can I give you another one?
Yes, sir.
And everyone in the room is welcome to try this. So I'm going to give you again, I'm telling you, this is an arithmetic. I'm declaring that this is an arithmetic. Okay, let's see if we got this, guys. Let's see if we caught this. 1 minus 2 and a -5. We need to find the general term for this. Okay, so first of all, we must find the constant difference. Remember, what are you going to do for the constant difference? I want to hear someone giving me an answer there. What's my constant difference here?
It's -3.
Very good. -3, very important. Okay, -3 is the constant difference. So that means I've got the -3n here. Now I must add something. I must add or subtract something at times. So as you can see there, I subtracted. So I must find basically the term that came before this one. So remember, what's the strategy? To get this one here, I would have said -2 subtract -3. And that indeed would have given me a +1. So now I need you to do the same thing here. There's a -3 here. So what should be this term?
1.
1.
It's 4.
4. Because you're going to go 1 minus what? -3. So that's going to be that term. Are you following? Don't worry.
Yes, sir.
In our next lesson, you're going to have a formula again to do this. But this is how we do it in grade 10. That's how we do it in grade 9. Anissa, are you okay now? Are you sorted? I think you had 2 questions. Are you fine with the first part of your question? How I found
Yes,
the
sir.
2n minus 1? You okay with that?
Yes, sir.
All right. Now, what was the second part of your question?
Wait, I low-key forgot.
I was somewhere here. The product thing, was it the product thing?
No, sir. I forgot, sir.
Okay.
Maybe I'm going to think about
Yeah,
it as
it's fine. It's okay. When you remember it, I want to believe you're in the WhatsApp group. So when you remember it, just send it in there, or you can send it separately. But yeah, when it comes
Yes, sir.
to ask that. All right. Is there any other question, Ntokozo?
Yes, I think her next question was how you got to 2n plus 1.
I see. This 2n plus 1 here. So Ntokozo, you're talking about this 2n plus 1 that I have highlighted or circled in yellow?
Yes, sir.
Okay, cool. So so remember, guys, the whole idea is we're trying to understand the concept of consecutive. Excuse me. One after the other. That's what we are trying to explain actually here and understand. So as I said, if if the one number that I've got is n, and I'm dealing with natural numbers, then the next natural number will be n plus 1. But how do I know this? Because if I know I've got a 2 and I want the next natural number after 2, that natural number will be a 3. The next natural number after a 3 will be a 4. So what is happening with natural numbers is they increase by 1, right? So all we were doing here, since we know the expression for Tn, we wanted to know an expression for Tn plus 1. And as you can see, I have actually substituted n plus 1 in the place of n. And then all I did was to simplify, multiply 2 by n, and then multiply 2 by 1 there. Okay. This, again, it's quite a foreign thing because we have not really done functions, but you'll see once we do functions and we do calculus, I will try and come back to this and you will understand it much better then as well. It might be blurry for now. And again, I want to say this, mathematics is a journey of patience. Some things we may not get right away when they are taught, but as we progress patiently, so we will actually get to an understanding. Okay. Are you with me?
Yes. Yes, sir.
All right, cool. So when we do functional notation, this is going to be very clear. It will be crystal clear. All right. Is there any other question? Not quite. All right, guys.
No.
All right. Ndogozo, you were saying something?
No, I don't have any other questions,
Okay.
sir.
No other question. All right, guys, we're gonna close it here for today. And yeah, thank you so much for tuning in. Keep checking the WhatsApp group. We'll communicate the next session. We will continue with the quadratic because there's still complex procedure questions to work on. I just want you to know this topic in depth. As you saw, about 26 marks go into number patterns. So in the next session, we're gonna just extend or go further from what we have done here. Otherwise, yeah, that's about it. Thank you very much. Yeah, I'll see you in the next session.